All right, we are in 7.3, and we are continuing on solving systems of linear equations, but in this case, we are um, using by adding and subtracting, and this is more popularly called the elimination method. Um, it differs from the substitution method, where the substitution method, it was you tried to get one variable by itself in one equation and then substitute the result of what either x or y was into the other equation and solved um, for the equation that it was presented. Here, we were trying to eliminate one and then we solve. So to keep in mind, we have to make sure that both of our equations are in ax plus by equals c form. Now, if you don't remember what that's called, that is called standard form. So you have to make sure that before you can use the elimination method, we must put it in ax plus by equals c form. And there are steps that we have to do in order to solve them. First step is we must add or subtract the equation to the eliminate one variable. And I'll show you what you'd have to do to either add or subtract them. Second step is solve for the variable that was not eliminated. And then once you do that, you substitute that value into either original equation and solve for the other variable. So let's look at some examples. So this example is two systems. We got 2x plus 3y equals 11. And then we have negative 2x plus 5y equals 13. So first thing that you have to do is you look and see if it's in standard form. And in this case, these two equations are. Once you do that, you must determine which variable you wish to eliminate. And how I always look at it is which um, two coefficients are the same. You see that I have the 2x and then I have a negative 2x in both different equations. So since I have the same number of a 2, that shows me that I'm going to eliminate my x first. Then you were dealing with adding and subtracting. So if you look that these two are opposites, one's a negative 2x and one's a positive 2x. If they're the opposite of each other, you're going to add them. You're going to add those equations together. If those happen to be the same coefficients, you're going to subtract. And since these ones are the opposite, we're going to add. So it's going to go right, you're going to add right down both these equations. So you got 2x plus a negative 2x. That cancels out to make it 0. Now I have 3y plus 5y. That equals 8y. Got the equal sign. Now I have 11 plus 13. That gives me 24. Now I can go to step 2, and I can solve for the non-eliminated variable, which happens to be y in this case. So I'm going to divide 8 by both sides, which gives me y equals 3. Last step is we substitute this value into either original equation and solve for the other variable. This happens to be x. So I'm going to use the top one. So I got 2x plus 3 times 3, because I know my 3 equals y equals 11. So I got 2x plus 9 equals 11. I'm going to subtract 9 to both sides, which gives me 2x equals, what is that, 2 divided by 2, x equals 1. So my ordered pair here would be 1, comma 3. Okay? Let's look at another. So I have example B. Are they in standard form? I got 4x plus 3y equals 2. Yes. I got 5x plus 3y equals negative 2. Yes, they are. They're in, both of them are in standard form. I'm looking for which numbers match up with the correct variable. I see that I have a 3y and a 3y in both of my equations. So this tells me that I'm going to eliminate the y in this case. So are they the opposite or are they the same? They happen to be the same. So that means that you're going to subtract both equations. And mainly what subtraction means is that second equation, you are just giving the opposite signs. So I have a positive 5x, which means if I'm doing subtraction, I'm changing the sign. So it's going to be a negative 5x. 3y was positive, so that's going to be a negative 3y. Negative 2 is negative, so that changes it to be a positive 2x. So then I have, now I can go 4x minus 5x, which gives me a negative x. These cancel, and then this would equal 4. So now I have negative x equals 4. I'm going to multiply both sides by a negative 1. So I got negative 1 here, negative 1 here. This gives me x, and this gives me negative 4. So my x value here equals a negative 4. I'm going to substitute in this negative 4 into the original equation. I'm going to use the top one. So I got 4 times negative 4 plus 3y equals 2. Now I'm going to solve for y. 4 times negative 4 is negative 16 plus 3y equals 2. I'm going to add 16 on both sides. This cancels, so 3y equals 18. And my y gives me 6. So my ordered pair, which is negative 4, comma 6. And mainly what we're finding here, these are the coordinates. If you were to graph these systems, these are where the lines cross. This for example, B would cross at negative 4, comma 6. Let's take a look at C. C, we have 8x minus 4y equals negative 4. We're in standard form. We're good. The second equation is not in standard form. So what we have to do is we have to subtract both sides by a negative 3. So this leaves me with negative 3x plus 4y equals 14. Okay. So I'm just going to put a line through it right now. So that's the original equation I crossed out, and underneath it is what it looks like in standard form. So now I see I have a 4y and a 4y, and I have a negative 4y and a positive 4y, so they're opposites. So that means I'm going to add both equations. So that means I don't need to change any signs. I'm just going to add them together. So I got 8x plus a negative 3x. That gives me a positive 5x. These two cancel, equals negative 4 plus 14, which gives me 10. If I divide both sides by 5, my x equals 2. Now it's just a matter of me substituting in that 2 into either one of these original equations to find what y is going to be. So I'm going to use the top one. I'm going to put 8 times 2 minus 4y y equals negative 4. Got 16 minus 4y equals negative 4. Minus 16 to both sides. That cancels that out, so I got negative 4y equals a negative 20. Divide both sides by negative 4. Ugh, that was an ugly 4. Cancel that out. Got y equals negative 20 divided by negative 4, which gives me a positive 5. So my ordered pair here is 2, comma 5. And that is, oh, I still got more. How about that? More fun. I'm going to give me some room here to work. There we go. Sorry about that. Okay. Let's tackle some more examples. D looks like it's in standard form. We're good. We got 3y, we got 3. Those are opposites, so we're just going to add them. We don't have to change the signs at the bottom. So we got 4x plus a negative 2x. That gives me positive 2x. These cancel. This equals, what, 5 plus negative 7. So that gives me, what, negative 2. So my x here is negative 1. Substitute back into the original equation. I have 4 times negative 1 minus 3y equals 5. Negative 4 minus 3y equals 5. I'm going to add 4 to both sides. Negative 3y equals 9. And this y equals a negative 3. So my ordered pair here would be negative 1, comma, negative 3. Last example. My first system, 3x plus 4y equals 6. That's the standard form. The second one is not. I need to get that 3x on the left-hand side. So I'm going to subtract both sides by 3x, which then gives me negative 3x plus 2y equals 6, which that makes it in standard form. I got 3x, I got 3x. They're both opposites. That means I'm going to add them. Means I don't have to change the signs. So 3x plus a negative 3x at 0. 4y plus 2y is 6y. And negative 6 plus 6 is 0. So my y equals 0. Just means I got to put this back into the original equation. So I got 3x plus 4 times 0 equals negative 6. 3x, that ends up being 0, so that's negative 6. And then divide both sides by 3. X equals negative 2. So my ordered pair is negative 2, comma, 0. And that is how you solve systems of equations using adding and subtracting, or what is more commonly known as the elimination method. Hope this helps. Until next time.